Hi guys, welcome to this Math 8. We're looking at day 21. We're going to be doing lesson 64 and 65. So lesson 64, we're using a unit multiplier to convert a rate. So again, a rate like miles per hour, dollars per hour, miles per gallon, something like that. So we can write a lot of these rates. Usually we use acronyms or words, MPH or miles per hour, but we can also write it as a fraction. And depending on what we're working with, we may want to use it, with hours in the numerator or maybe in the denominator. So we want to cancel out. So to convert rates to alternate units, we create a unit multiplier using the appropriate units. Then we multiply the rate by the appropriate unit, multiply to cancel the unit we want to eliminate, include the unit or units we want in the answer. So Yasmin ran a mile in 6 minutes. Use a unit multiplier to find your average rate in miles per hour. So again, that's great to know how fast you ran, but you want to figure out, miles per hour. So you did a mile in 6 minutes. So miles per minute. So what do we want to end up with? We want to end up with miles per hour. So miles in the numerator. Okay, check, we got that. Minutes we want to get rid of, and right now minutes is in the denominator. So in order to get rid of it, I need it to be in the numerator so it can cancel out. And then I want hours down here because I want miles per hour. So we know 60 minutes is equivalent to 1 hour. So when I multiply this, I get 1 mile times 60 minutes, but minutes and minutes are going to cancel out. So I'm going to be left with 1 times 60 over 6 times 1. And then 60 divided by 6 is 10. So if you run a mile in 6 minutes, you are traveling 10 miles per hour. So again, set up with what you were given and figure out where you want to end up, and that's going to tell you where you put your units for your unit multiplier, so that way you can cancel out whatever you want to. Driving at 60 miles per hour, a car travels about how many kilometers in 2 hours? And so we're going to set up 60 miles per hour, so we're going to have miles per hour. And we were told it's on your reference sheet if you need it, but 1 mile is about 1.6 kilometers. So I want to end up with kilometers per hour. So I want to get rid of miles. So I want miles down here. Hours is going to stand. I want kilometers here. Multiplying. So 1.6 kilometers for 1 mile. Miles and miles are going to cancel out. 60 times 1.6 is 96. And then 1 hour times 1 is just 1 hour. So 96 kilometers per hour. But we're not done, because we're told that we want to figure out how much that would be for 2 hours. So we could have doubled it 120 miles in 2 hours and then converted it. We got it to kilometers per hour. Now we just need to get rid of our hours, so we end up with a distance. Hours and hours would cancel out, so 96 times 2. We know this is kilometers per hour. We can just multiply that by 2. But when we're doing that, we are canceling out the hours. That's why we're showing it, because hours and hours cancel out, and we're left with just a distance, which is 192 kilometers. These practice set problems we'll go over when we get back to class. The second one we're looking at is applications using similar triangles. So similar again means that they have the same angle measurements and the side lengths are proportional. So this can be really helpful when we use indirect measure. So if we look at example 1, okay, Mary Cruz wants to know the height of a flagpole. She stands a meter stick in a vertical position and finds the length of the shadow is 120 centimeters. At the same time, the shadow of the flagpole is 30 meters long. How tall is the flagpole? Okay, well, we have 120. There's our 100 centimeters, our meter. Again, we needed to convert that to centimeters. They got that for us. And again, this has to be the same time of day, the same position, because it's going to create, again, a right triangle and a right triangle that are going to be similar. So now we can use the length of the shadow to calculate the height of the pole versus trying to run a tape measure up there or climb up there or something. We can use this indirect measure to make it a little bit easier. So if I have a right triangle here and here, again, they're meeting at the ground, assuming they're a right angle. This angle and this angle, this angle and this angle are going to correspond, and then all the side lengths are going to be proportional. So we're told it was 100 and 120. This was 30 meters. That would be 3,000 centimeters, and we want to know this height right here. Or we call it P for pole or whatever. So we're going to set up these in proportions. So we'll do 100 to 120. Okay, equals, okay, so 100 to 120 equals X or P or whatever we're calling it to 30 meters, because we want to end up with meters. We could do it in centimeters, then convert it back to meters, but since it's going to make more sense to give the flagpole in meters, we'll go ahead and just leave it in meters. So we cross multiply. And then we divide. So X equals 5. And again, in looking at, well, 120 is a little bit longer than 100, 30 is a little bit longer than 25. Yeah, it makes sense that that's what we come up with. So instead of trying to climb 25 meters or get that measurement somehow, we can use indirect measure and what we know about similar triangles to calculate that. So as you guys get bored over summer break or something like that, and you're just really missing math, you can go outside and start to measure shadows. So using indirect measurement. And sometimes we have distances that, maybe we can't get to, or it's too dangerous or whatever to measure. So we can use this and what we know about similar shapes to calculate the measurement. So I'm not going to try and redraw this lake, but let's take a look. Josh stood facing a pond. From his viewpoint, he could see 2 points on the opposite sides of the pond, point 1 and point 2. He wanted to know the distance between point 1 and point 2, but he did not have a way to measure distance directly. Again, he couldn't plant something on both sides and swim across and with a tape measure in hand or use some sort of laser measure or something. So he had an idea. He could indirectly measure the distance. He marked his position with a large stone, walked 10 yards towards point. 10 yards to point 1, and then drove a stake into the ground. He tied a string around the bottom of the stake and stretched it out in a line parallel to the line from point 1 to point 2. Josh then returned to his starting position and walked a straight line to point 2. When Josh reached the string, he drove another stake into the ground and tied off the string. So basically, he started here, he walked here and here, drove 2 stakes, and then connected it with a string. So we have a right angle, a right angle. We have them sharing this angle, so we know this third angle has to be the same. So if all 3 angles are the same, then we have similar shapes. So we have 2 similar triangles right here, so we can use proportions to solve those. So he knew the distance from point 1 is 45 yards. If the distance between the first stake and the second is 8 yards, the distance from point 1 to point 2 across the pond is how many yards? And so we have 10 yards and 8 yards, and then 45 yards to point 1. So we want to find this distance here. So we're going to, these angles are the same, these are the same, and these are the same. So 10 corresponds with 45 and 8 with x. We're going to say 10 to 8 equals, and we can do 8 to 10. We just got to make sure that they're in the same position. So 10 to 8 equals 45 to x. We cross multiply and divide. So we get 10x, 8 times 45 is 360. Cross multiply and divide, 36. So in looking back at this, if this is 45 yards and these are proportional, then this is about 36 yards. Okay, we can find the scale factor also. Scale factor from 45 to 10 is 4.5. This is 4.5 times bigger than this. We can also say, well, 8 times 4.5 is 36. So we can set it up and use cross multiplication and division, or we can find a scale factor once we know which sides correspond with which sides, and then apply that. Okay, that is all we have for today. We'll do these practice set problems together in class when we return. Have a good one.